What is up, everyone? So in this lecture, we're going to discuss phospholipids. What a surprise. And we're going to discuss, we have a couple boards for this one. So specifically phosphatidylinositol, which is a glycerophospholipid. This is going to be formed, as we saw previously, by the diacylglycerol using inositol, activating diacylglycerol with CDP, plus this inositol giving. We're going to get rid of phosphates and CMP, and we're going to make a phospholipid. What's unique about these is these have a C1 with stearic acid and a C2 with arachidonic acid. And what I mean by that is the fatty acid chains here in green, arachidonic acid at C2, stearic acid at C1. Just have to remember these are the inositols here. Signal transduction, remember arachidonic acid plays a role in signal transduction, so these phosphatidylinositols also play a role in signal transduction pathways. So the PI will be phosphorylated to PIP2, so phosphorylation will occur, and there will be phospholipase C, which can cleave PIP2 into IP3 and diacylglycerol. And what's important about that is IP3 is a calcium mobilizer, so we'll get the calcium, and the diacylglycerol will activate PK, protein kinase C, and calcium also will, but this will all lead to cell will respond to the hormone or neurotransmitter or whatever is binding. So this will allow for signaling to occur. And this is the bond that's going to cleave the CH2 and phosphate. That's where you're going to cleave the the PIP2. So you have your phosphate up here, your CH2, so you'll cleave right there. And then you'll be left with your diacylglycerol here, and then your phosphatidyl, your IP3 here. So you'll have 3 phosphates actually on it. These are embedded in membranes, of course. And that's this slide, I believe. We're done with that. But basically the whole point of that, well, we'll go back through it, but let's talk about this real fast. Membrane protein anchoring. So it's an important component for membrane anchoring proteins in membranes. And several proteins are alkaline phosphatase that will anchor, acetylcholine esterase, and lipoprotein lipase. These are all enzymes, right? And these will be anchored to phosphatidylinositol. What's important about these anchoring is, if you have low glucosal phosphatidylinositol, this is, a type of phosphatidylinositol, so low GPI, you can develop a disease called paroxysmal, it's a hemolytic disease, paroxysmal nocturnal hemoglobinuria. So that's a mouthful. Paroxysmal nocturnal hemoglobinuria. This is where the loss of the protein anchors, right? You don't have the protein anchor, phosphatidylinositol. The loss of that anchor will allow red blood cells to lyse, hemolysis, they'll split. And you'll get hemoglobin or red blood cells in your urine. And this is because the anchoring of the proteins will protect the red blood cells from complement-mediated lysis. So without the anchoring, they will get lysed by the complement pathway. Phospholipase C will detach protein, right? So when they bind the proteins, phospholipase C can detach the proteins, and the inositol phosphate will leave, and diacylglycerol as well, and you activate the protein kinase C. And here it's showing the molecule, the phosphatidylinositol, in the lipid membrane, and these are lipophilic tails embedded in this membrane. So to recap, basically, we know how this is made. You have a couple important features on the carbons here, stearic acid, arachidonic acid. These are important for signaling, and they do this via this hormone binding to a G protein couple receptor, and then you get like some stuff going on and more stuff, and then basically you're gonna have a signaling transduction occur. Anyways, hope you all enjoyed that. That's it.